Hey guys, it's Will. So I'm going to talk you through setting up a storage node on the V3 network on an Odroid HC2 device. So you're going to need to get yourself the Odroid HC2 to set your node up. I'm in the UK. I purchased mine from odroid.co.uk. You can see here the website. These are also available from hard kernel if you're outside the UK. And just to let you know as well, the HC2 accommodates the 3.5-inch size hard drives. If you happen to have an SSD drive, you can purchase the HC1, which is just the same thing. It's just a smaller chassis for the smaller hard drives. So in addition to the HC2, you're going to need a 3.5-inch hard drive. Here I'm using a 10TB Barracuda Pro and also an SD card. I should mention that the Odroid HC2 actually only accommodates a micro SD card, so just be aware of that if you're purchasing one. I don't actually have a micro SD card or an SD card slot on my machine, so I'm using this USB micro SD adapter, which basically means I plug the SD card into the USB adapter and then plug that into my machine, which then displays as kind of a normal USB kind of drive. So we now need to download an operating system onto the SD card. So I'm going to go to wiki.odroid.com and find an image that is suitable for the XU4 device, which is basically the hardware attached to the HC2. So I'm going to click on there and try and download a minimal image. I'm specifically looking for an Ubuntu image. The latest version that's on there will be great. And I'm looking for the minimal image because the HC2 is a headless device. It doesn't have a HDMI port on there, for example. You don't need to run the GUI. So the minimal image basically is kind of the bare operating system without that GUI. Once you've downloaded the operating system image, we need to transfer that to the SD card, but you can't just drag and drop it. You need to kind of extract it and transfer it correctly. To do that, we're going to use some software called Etcher. You can see here I've just downloaded that. It's really simple to use. You just browse with the image that you want to use, you browse to the SD card location, and you click burn. And it does take a few minutes, but you just wait for that to complete, and it will say complete when it's ready. So all you need to do now is connect up the hard drive. That's really simple. It just slots in. There's a couple of screws to put in there, and slot the SD card into the slot. Obviously you need to connect an RJ45 network connection and power. So as soon as you connect the power to the HC2, it's going to boot up. Because it's headless and it hasn't got a monitor or anything plugged in, so the only way that you can kind of see activity on there is to look at the little LEDs on the device itself. They are quite small, but they're pretty obvious. The one you want to look out for the first time you boot it up is the blue LED. After about 60 seconds or so, that will go off, which means there's no activity happening. Just for the first time, you need to let it go off. It takes about a minute. Then if you turn the power off to the HC2, give it a few seconds and turn the power back on, then it will kind of boot up normally. I'm not exactly sure why that is. I'm guessing there's some kind of extraction process the first time it boots or something, but you do need to turn it on once, let it do its thing, turn it off and turn it back on again. So because the Odroid HC2 is headless, which means we haven't got a monitor connected, we don't know what the IP address of it is. So what I'm doing now is running some software called Angry IP Scanner. Just Google that if you need it. There are other ways to work out what the IP address is of the HC2. You could log into your router page, for example, and see what the device is called. I'm just using Angry IP Scanner. You use what you need to. But all I'm doing here is scanning my local network to find all the devices to work out which one is the HC2. So I'm just going to sort the host names just to bring them all together, and you can see it's pretty obvious which one we're looking at. The one we need is called Odroid, and in the IP column it tells me what my IP address is. So I know that it's 192.168.168.138. So by default, the Odroid is looking for a DHCP address, not a static IP. So as long as your router or network has got a DHCP server on there, it will automatically get an IP address, and you just need to find out what it is. So now you know the IP address of the HC2 on your network, you need to open up a command prompt or a terminal and connect to it via SSH. So this can be a bit daunting if you've not done it before, but if you follow these instructions, it's pretty simple. I've gone through these several times to make sure that they work. As I'm recording this, they do work, but if there's any changes in the future, I'll try and keep this updated or some comments. Basically, to connect, you need to type in SSH and then a space. The username, which in this case is root, so it's ROOT, and then the @ symbol, and followed by the IP address that we've found out in the previous step. So it's SSH space root @ IP address. As you can see here, if you hit return, it gives you a security warning for the first time. Just type yes to that to accept it. Then it will ask you for the password, and the default password is Odroid. So just type in Odroid, hit return, and then it kind of takes you to this command prompt here where you're ready to start typing in commands. So I'm going to put all these commands in the description so you can copy and paste them yourself. The first thing we need to do is install something called parted, which we're going to use to format and partition the drive. Bizarrely, the first time I tried running this, it doesn't work and it gives me the error that you can see here. All I do is, I tried running it again, it still doesn't work. All I'm going to do is turn it off, turn it back on again, and run the same command after logging back in, obviously, and then bizarrely it works. So if you get an error at this point, just turn it off, turn it back on, re-log in via the SSH, and get back to this point. So I've rebooted, logged back in, ran the same command, exactly the same command, and hit return, and you can see it's working. So if you do get that issue, just make sure you reboot. It does ask you if you want to use some additional disk space to install it. Just hit yes to that, and give it a second, and it will install pretty quickly. So the next command we're going to run is lsblk. Again, I'll put this in the comments. You need to run as lsblk and to identify the disk that you've installed in the HC2, what it's called on the system. You can see here that the disk I'm looking for is SDA. You can see it says it's a 9.1 terabyte disk. So you just need to make a note of that. I'll just highlight that here, and you need to incorporate that into the next command. So you can see there that I've got the 9.1 terabyte disk. So my next command, and again I think this probably will be the same for everybody because the hardware should be identical, but I'm just going to edit the next command. So the next command is sudo space parted space /dev/ and then the disk identifier. So I've just identified that mine is SDA. So if yours is different, just to correct that, but I'm pretty sure it will be the same. Hit return, and that's basically opening up parted, which we installed a couple of minutes ago. Our next command is mklabel gpt. So again, I'll put all the commands in the description. Just type that in. Then you do get an important warning here to let you know that all the data on the disk will be wiped. So just make sure that this disk has not got any info or data on it that you need to keep. It does force you to type in the word yes to continue, so type in yes and then hit return. Our next command is to tell it the unit in terabytes. So we type in unit space TB, hit return. And the next command you will need to customize depending on the size of the disk that you're using. So you can see here that my command is mkpart primary, starting at the beginning of the disk at 000 TB and finishing at the end of the disk. So I'm using the full size of my disk here to make that partition. So the bit that you will need to customize is the bit that I put at the end here. So where I put 9.10 TB, you will have to use the value that you saw earlier on. So after you've created that partition, you just need to type quit and hit return. It will give you some information there that says you may need to update the fstab file. So now what we're going to do is format the disk. So the next command is sudo mkfs.ext4, so that's make file system as an ext4 file system, and then a space and then /dev/sda. Again, I'm assuming the SDA will be the same for you, but that's again the disk that we identified earlier, so just make sure yours is SDA. And if you hit return on there, I get a warning to say that it's found a partition table. Do you want to proceed anyway? Just type yes, hit return, and then it starts creating the file system. Just another command to run here to tune the file system. Again, just make sure the SDA bit at the end of that command matches your disk, hit return. And our next command is to mount the disks. This is pretty important. Again, just make sure the SDA in there is the same as your disk. We then need to edit the fstab file. So just type in that sudo nano command. This kind of opens up the editor of that fstab file. You then just need to use the arrow keys on the keyboard just to go down to the next available line and paste in the next command, which is /dev/sda. Obviously replace that with your disk if it's different. Then you just need to save the file. To save it, there are instructions at the bottom, but you just do Shift and O, hit return. That will just write the updates to the file, and then we need to exit this editor by doing Shift and X. We now need to test that the drive mounts itself when the device reboots. So just simply type sudo space reboot, and the HC2 will reboot. You can see here that it's closed the connection, obviously because it's rebooting. If you give it probably takes maybe 30 seconds or so to reboot. Once it's rebooted, you will need to log back in. So you need to type in the SSH space root at the IP address. Obviously give it a few seconds to reboot before you try that. Hit return and you'll be prompted for the password again. So now we've configured the HC2 with Ubuntu, we've mounted and formatted the disk, and the disk is now available to the operating system once it reboots. So pretty much all the steps that we've performed so far are useful to anybody at this point. What we're doing now is optional, but I highly recommend it. What we're doing is copying the operating system and all the configuration that we've made so far from the SD card to the actual hard drive itself. The purpose of this is SD cards are pretty notorious for failure after a relatively low number of read and writes. So we're kind of taking the SD card out of the equation as much as possible, and making the operating system really do all the reading and writing directly to the hard drive. So there's a couple of commands here that we're running. Again, I'll put those in the description, but if you run those, that will basically copy all of those files from the SD card to the hard drive. We're now going to run lsblk space -f, and what we're looking for here is to get the identifier of the disk that we've been working on, the one that we've formatted and partitioned. So looking at this list here, you can see the one that I need is the SDA. You can see it's got the ext4 file system, and you can see the mount point is just /mnt. So what we need to do here is take the UUID, and we're going to copy that. I recommend you just put it in a text file or something handy, because you are going to need that in a couple of places for the next steps. So just to recap, what we've done so far is copy the operating system to the hard drive that's in the HC2. Now we need to edit 3 files to make sure that the Odroid HC2 actually boots from the new location on the hard drive rather than on the SD card. So similarly to what we did earlier, we're going to edit the boot.ini file, so you can just paste in that command. What we're looking for here is the set env space boot root fs line. So I'm just going to navigate through this file looking for that line, just using the up and down arrow keys. So we've found the set env boot root fs line, and what we need to do now is take out the existing UUID reference in this line and replace it with the one that we copied earlier. So you need to be quite careful with this. You need to make sure you retain all the correct spacing as it appears right now. And once you've done that, simply save and exit as you did previously. So that's Shift and O, and then hit Enter to save it, and then Shift and X to exit. The next file that you need to edit is the boot.ini.default file. It looks very similar to the other one, but it is different and you do need to do it. This is basically repeating the same process. You need to replace the UUID, although one very important difference is that you'll notice that this file obviously is a lot shorter, but at the beginning of the boot root fs line, it's commented out with that hash at the beginning of the line. The hash just basically means it's commented out and that line is not processed in the code. So you need to remove the hash, which will make the line active, and also replace the UUID. And again, you need to save the file with the updates and exit. So that's Shift and O, Shift and X. We now need to edit the fstab file. So again, nano / and the file path. And you've probably guessed already that we're going to replace again the UUID with the one that we've saved earlier on. And of course remember to save the file updates and exit in the same way. So all we need to do now is basically test that everything still works, and to do that we're going to do a sudo space reboot again. The 3 files that we've just edited are all pretty important to the boot up process, so we need to check that it reboots correctly to make sure everything's still working. So it's just sudo space reboot. We'll give that a few seconds to reboot, and then we will try and connect back to it. So SSH space the username, which is root, at the IP address, and hit return and enter our password. And as you can see, that's logged in successfully. So everything's working, that's great. So congratulations if you've got this far. And the next thing you need to do now is set up the storage node software on the HC2. So now we're getting into the good stuff. First thing we're going to do is install curl, which we're going to use to download a file in a moment. So basically just, again, type the command sudo apt-install curl, press yes when it asks you to use the additional disk space and let that install. So what we're going to do now is basically follow the instructions on the Storj GitHub page. So the HC2 is obviously an ARM device, if you don't know that by now. So we're going to find the first step in the instructions, which is to download the identity file. So we're going to right click on the Raspberry Pi ARM option and copy that link. Then here I'm going to paste a command, which is curl space, and then the link that we've just copied, then a space, and then a little bit afterwards, which tells it what to call the file when it's downloaded it. The reason I'm telling you how to do this, rather than just giving you the link to copy and paste, is that this may be updated. So it's important that you update this URL with the file which is current from the website, and hit return. That will then download the file. The file that we downloaded was a zip file, so we're now going to install a utility to unzip it. So that's sudo apt-get install unzip, just hit return, it will install. Now that you've installed it, we can extract the file that we downloaded from the Storj GitHub site. So again, you can just copy and paste that from the commands I've left in the description. That will work as long as you use the same format as provided earlier. Just hit return, and that has now extracted that file to that in that location. So the file that we've just downloaded is to create the storage node identity. Now this is intended to be quite difficult and to prevent somebody spinning up loads and loads of storage nodes very easily. So what we have to do now is run this identity generator. It does require a fair bit of CPU power, and will take a fair bit of time to run on the HC2 because it is an ARM processor. So this will take between, I don't know, a couple or maybe 24 hours max. I've run this a couple of times just out of interest, and generally it's generated one within about 12 hours. So just keep this running, and you'll know when it's finished. It will stop generating keys, and it will say that it's generated an identity either 30 or higher, which is what it's trying to do. Okay, so while I was waiting for that, I switched over to a Windows machine. Everything just looks a little bit different, but it works exactly the same way. So you can see that we've generated a key of 33 difficulty. So now that we've generated our identity, we need to sign it. So signing the identity is a requirement in alpha. I'm not sure if this will still be a requirement in beta or production, but for the moment you have to join the waitlist on the Storj website, and you are provided with a special key which you need to sign using the identity. There are instructions in the email, but the command I've typed is at the top. I've obscured the email address, and the key after that is unique anyway. We're now going to install Docker. So the storage node actually runs in Docker, as you probably know. So there's just a simple command to run that and install it. So again, I'll put that in the description. So that's installed nice and quickly. Then we're going to run another command to create a folder, which we've run there. And now we are going to run another command to pull down the storage node image for Docker. Now we need to run the storage node image. There's just a fairly long command that we need to run now. Take your time configuring this and checking it's right. So there are some unique values in here that are just for me: the wallet email address, the address field, which is the IP address of my router, bandwidth, storage, those kind of things. You need to customize those specifically for you, so do check those against the instructions against the GitHub website. Now we're going to run a final command to launch the storage node dashboard, which is really useful. It gives you some great stats on what's going on. Just a quick point here that the last contact for me says offline. That is not normal. It should say 0 seconds or anything between 1 and 5 seconds or so. The reason this is offline for me is because I need to do another step now. I need to log into my router and forward port 28967 to this storage node that's running. So with that in mind, you may want to set a DHCP reservation in your router so the router assigns it the same internal IP address all the time, or you could configure the storage node with a static IP address. I wouldn't particularly recommend that since it's headless, and if you make a mistake, it's really difficult to correct. So I'd recommend setting a DHCP reservation in your router, which most routers you can do that these days, and then you need to set the port forwarding. Once you set the port forwarding, you should notice that instantly that offline will change to 0 seconds, 1 second, 2 seconds, or something sub 5 seconds. The final thing that we're going to do is just exit out of that storage dashboard just with Ctrl-C, and we're going to run the command which will automatically keep the storage node image updated with the latest image. So we're just going to run this command called watchtower. Again, check out the install instructions on the GitHub website to make sure everything's up to date on there. But nothing happens after you run that. You just run it, and that's it. And next time there is an update, if you do happen to keep the Storj node dashboard open all the time like I do, it will lose connection and you simply reconnect. That's it guys, you're all set up. I hope you've enjoyed the video, and thanks for sticking with me till the end. It's a bit of a long one, but I really do appreciate you watching. If you do have any feedback, feel free to let me know in the comments, and also your thoughts on the HC2, the HC1, and if there's any better hardware to use, anything like that, greatly appreciated.